So where we are here, we're above the UK's deep underground science facility here at Bolby Mine. Bolby's a working potash mine here in the northeast. It's the deepest mine in Britain, and beneath our feet is this deep underground science laboratory, one of just a few in the world that laboratories that allow you to do science that you need to be deep underground for.
Well, this project's all about carbon capture and storage, at least the storage end, the way of mitigating some of the emissions of CO2 to the atmosphere, greenhouse gases, of course. And what we're trying to do here is develop new ways to monitor CO2 when it's injected beneath the Earth's surface. The key thing is once we inject the CO2 deep, maybe 1 or 2 kilometres underground, we need to monitor it. And at the moment, the only way of monitoring it is to use an expensive seismic survey, run it once a year, second year, third year, and so on. You only have information when you shoot it. The technology we're using here has the potential for measuring it 24/7. Essentially, the signal is free as well. This technique of monitoring CO2 with muon tomography is successful, it will radically reduce the cost of monitoring and therefore make the whole process of carbon storage, mitigation of climate change that much more possible.
It's an unusual but very enjoyable situation to actually be, first of all, from my perspective, taking my particle physics know-how and applying that to very much a sort of a topical and crucial question. But it's a pleasure as well to be working with colleagues, for example, from the University of Durham in the Earth Sciences department, and colleagues also from Bath and, as you say, NASA, etc. So it's a great example of interdisciplinarity working at its best, and it's a great group of people to work with.
Well, this is fascinating science, and my department has contributed to it, but here we're at the leading edge. If we're going to deal with CO2, and everybody wants to deal with CO2 emissions, we've got to find somewhere to store them. And this is all about finding a safe method of storing them in underground reservoirs, and we get to be sure of the integrity of those reservoirs. And today I've been down and I've seen scientists who are at the cutting edge of this, who are ahead of the rest of the world. Durham University in the lead, but contributions from oil companies that have been working in the North Sea, a range of other scientific expertise. And this is all about establishing ways of checking the integrity of the reservoir and being able to do so in a reasonably cost-effective way without drilling borehole after borehole. So we have here a mining operation combined with a very important piece of scientific research, a lab right underground. I think higher education's gone through a revolution in the last 20 years. There's much more understanding that there are technologies now that can be commercialised. But what's really important about this is Britain is leading the way in carbon capture and storage in terms of Europe. The Canadians are doing some work on it, the Americans are, and if we're to take gashouse emissions seriously, we have to find a way of storing it. And the answer may just lie in the science that's being done in the laboratory here.